So graphing our trig functions now, of course we looked at graphing trig last year, but we really just did the very basic sine x, cos x, tan x. Now we're going to look at, well, what happens if the angle is some other linear function. Let's first of all look at the sine curve. Now again, let's look at the basic one first of all. We know the amplitudes from 1 to -1. We mark off our divisions. Well, it used to be, I'd say, every 90 degrees, but now we're talking radians, so it's every pi on 2. You notice I don't bother labelling the pi on 2, probably because I'm lazy. I just label the multiples of pi. And I've gone a bit silly because I've gone all the way to 4 pi and back to -2 pi, but it doesn't matter. So our sine curve, you remember, we start at the origin and then we go up and down, and it basically zigzags all the way backwards and forwards. But of course we don't draw a zigzag, it's a nice smooth curve, and there's y equals sine x, our standard one. So the sorts of things we like to know about functions: domain is all real x for sine, range is in between -1 and 1. What else can we tell? Oh yes, some other terminologies we now have, because we're going to look at more than just the standard one. So the period of a trig function, and a period basically is how long until it repeats. So when is it back at the same spot? But not just back at the same spot and going in the same direction. Because otherwise, if you were to look at, say, here I am at 2 pi 0, well, it only takes me pi to get back to 0. But at 2 pi we're going up, 3 pi we're going down. So it actually takes 2 pi till we're going back up again. So it doesn't matter which point you pick on that particular one, it always is going to take 2 pi until we're back at that same position. And amplitude is basically how high up, how far down it goes from the axis. So if I was to generalize our curve, so put any linear function we like as the angle, so bx plus c, and it could have a coefficient out the front a, what ends up happening, the period will always be 2 pi divided by the coefficient of x, whatever the coefficient of x is. The amplitude is the coefficient of the trig function itself. Now, there is another thing I like to work out, and that is simply how much am I going to mark off? Well, in each period there's 4 key points. So I always divide the period by 4, and then that's what I'll label. I mean, I could use the same picture for every trig graph and just change the labels. If I have to do more than one on the same, I can't get away with that. But if I'm only drawing one trig graph, I can always draw the same graph. That's where those math aids are handy, because you just grab that and go and make the scale fit the picture. And there's a shift, but be careful, the shift is not C, it's C divided by B, because remember the shift is when it's grouped with the X. So if we were to factorise the X, we've got that common factor of B in the two terms, so the shift is actually C divided by B. C divided by B. So let's have a look at this one. 9x minus pi on 2, 5 sine. So how would I do it? I've got to work out the key features. The period is 2 pi on 9. Amplitude is 5, so I know I'm going to mark off pi on 18 is going to be my scale. And this one is shifting pi on 18, so it's pi on 2 divided by 9. And it's negative, so we know we're shifting it to the right. I deliberately picked those numbers nice so that the shift was the same as the divisions there. Okay, but you see I'm drawing up exactly the same graph. But on the amplitude, instead of writing 1 and -1, I'm writing 5 and -5. And on the divisions, instead of writing multiples of pi, I'm now doing multiples of pi on 9. So each division there's pi on 18. And basically I draw the same graph. It's a sine graph, but it's shifted. So instead of starting at 0, because I'm shifted pi on 18 to the right, I start at pi on 18. But the pattern stays the same. So we go up, down, backwards, forwards, and draw in the sine curve. Now, okay, what about cosine? Well, remember the cosine and the sine curve are the same graph. It's just the cosine graph is the sine graph shifted. So all these things are going to be the same. Period's 2 pi on B. Amplitude's A. Divisions, I'm still going to mark off period on 4. It's still going to be a shift C on B. So which one did I pick for this one? Ooh, look at this, we've got a lot happening. -4 cosine x on 8 plus pi, all of that plus 2. I've gone a little bit crazy. I don't know that I've ever seen them ask every type of shift possible, but see how we go. Okay, period 2 pi on an 8, so the period's 16 pi. Amplitude is 4. The negative is going to mean it's upside down. I'll mark off the divisions every 4 pi. So we've shifted 8 pi to the left. We're going to shift 2 up. And as I say, the curve's upside down as well. Let's draw our axes. Okay, so amplitude's 4. Normally I'd mark from -4 to 4. But this whole thing is shifted up 2. So I'm going to mark in a horizontal line there because I'm going to have to plot points along the axis. So that's just going to help me do that. So 2 is now going to become the axis, and we're going to be going from -2 to 6. Now, horizontal one, let's put those divisions in. So every 4 pi, but again I'm just marking in every second one there. Now, a cosine curve would normally start 0 and I'm at the top of the amplitude. This one has shifted 8 pi to the left, so I'm now starting at -8 pi. It's moved up 2, so it's up at 6, but it's upside down, so we'll start down there at -2. So instead of starting at the top, we're going to start at the bottom. And then from there it moves to the axis, up, down, up, down, up, down. And come on, there we go. And so there's our graph for the cosine graph. Tan. Alright, so generalize the tan curve. The period for a tan curve is not 2 pi and b. If you remember your tan graph, the basic one repeats every 180 degrees or every pi. So this one's going to be pi divided by b. Amplitude really has no meaning with a tan graph. Again, if you remember what your tan graph looks like, it goes down to -infinity up to positive infinity. So my divisions now will only be period divided by 2, because there's only 2 key features in the graph. And there'll be C on B to the left, that's still the same. So what have I drawn? Oh, E times tan pi x minus 2 pi. Okay, period is just 1. Divisions, I'll mark off each at 1/2. My shift is just going to be 2 to the right. Let's draw a picture. Well, there is no scale on the y-axis because we don't have an amplitude for tan. So I'll mark off the divisions along the horizontal axis. There we go, 1, 2, and so on. Now, let's plot in. Normally, again, tan graph, 0, 0. But this one is shifted 2 to the right, so I'm starting at 2, 0. And if you remember the pattern for the tan curve, it goes x-intercept, asymptote, x-intercept, asymptote. So let's draw those. There's an asymptote on the right, then going back the other way. There we go, x-intercept, asymptote, and so on. And we draw in our tan curve. Now remember, when you're drawing a tan curve, it does not look like the cubic. It is not a horizontal point of inflection. It inflects at 45 degrees as it goes through, like so. And we just repeat that picture. The E out of the front was kind of irrelevant because of the amplitude, but it looked nice. Okay, I think that's just all. That'll do us for today. Just spend the day drawing up our trig graphs.